18 and life to go. We're working on 300's Sweet 16. First time I've ever seen this. Apparently the last hands it went through was my good friend Tony over there at ICA, or one of the associates that work over there with him. I'm a little bit interested to see what we got going on in here. Hello everybody, it's your friendly neighborhood amplifier technician here today. I don't know why us as craftsmen in this industry have such a hard time with just slowing down, cleaning everything up, making everything look pretty, putting the fuses in the right place. I don't know. But it's done. This is got all the right parts in all the right places now that I can gauge. I won't know for sure if we're actually running in balance until we actually put power to it and run it here in a minute. I rewired the entire remote section. So it makes sense to me anyhow. This is your fan hookup. Okay, and this is your remote switch here. So the center tip is hot, and then your jacket pin on return is going to be your on, so standard. And yeah. Wait a minute. Got this labeled fan, and this one's remote. I wired this backwards. Hold on one second. Bias caps are chooched. All different value resistors. Okay, so just a quick cursory examination of what we have going on here, boys and girls. We've got real deal red dot Toshibas. These two are blown. This is obviously seen Hard Day's Night. Zoom in here so you can see it. Combiner has seen better days. This combiner has also seen better days. It's okay. We got better technology. We can fix that. That's not a big deal. Our 1.8 ohm resistor for our sideband, all different. These are all different. Yeah. So we got our work cut out for us. All right, let me call 300. You ever have one of the minutes where or moments, or just a part of your day where you feel like you're kind of stuck between a rock and a hard place? I'm having one of those right now. My buddy 300 is insistent that he got this back from getting repaired. He hooked it up like once, he thinks, and then he sent it up here to get the power wires upgraded. And I'm like, okay. The output combiner here, this is our primary output combiner, is melted. The varnish on these wires, on this mag wire, is burnt. And the same thing going on here. So these have to be replaced, no matter what. I don't care who did what. I don't care. I don't know what this is all about. This is going to get removed. This doesn't need to be here. Doesn't need to be here. There's a diode here and a diode here, and there's a diode right next to it. I don't understand what's going on. There's another diode right there. We went ahead and we pulled all the power wires out because I wanted to open this space up for all of us to look at. The great debate is what happened here. Now if we look at these transistors here, we'll see that they're 1H. But then when we look at these here, they're 8D. I'm assuming these transistors are bad, taking into account the 10 ohm resistors here and here, obviously, that are burnt. But then looking at this over here also brings me to the same conclusion. Now, I don't know. It's my job to fix the box. Okay, so I'm going to pull this whole 2-pill section apart. We're going to lift the transistors out of here very carefully, and we're going to test them. And I mean, we're going to do it in one continuous homogeneous shot. So I got to get geared up for that, and then when I come back, it's going to be like zipping out Allen wrench screws. I mean, we're going to pull these resistors out, and then we're going to zip out the Allen screws, and then we're going to lift these out, put them on a piece of paper, and we're going to test them. The odds are, from what I see here, these two transistors are popped. Now we know if we blow these transistors, we automatically want to come back and check this little resistor right here. Every time. So before we go any further, we're going to check that. Then also in turn, this is a stock valued resistor. I'm going to check it. This one here, we're going to check it as well, because it's obviously been popped or replaced. And the same thing going on here. This would be the size of a resistor that you'd use to control the bias on a 1x2 section and like a 667, because the bias circuit they're parallel on the 1-pill section, and then half of the 2-pill section on the final section. So we're going to check all of these. Trust not, we're going to verify. We're not going to trust anything. We want to verify and see what we got for data. So, I don't know, 300 is my friend. Those guys over there, they're all really good friends of mine, and I've got nothing negative to say about anybody. I'm just here being told what the story is, and I'm not dragging anybody through the mud. I am doing me. And for the record, I've never cared for this style of circuit right here. This is dangerous and dumb. If you've got to add capacitance, focus. If you got to add capacitance, you do it here. Post combiner, one cap, not here and here. All it takes is for one of these caps to fall a little bit out of variance and the whole thing goes to shit. So this is dangerous. And they figured out later on, all you got to do is not even have capacitance here, and you add your total sum capacitance here at the output. And then they had a glitch resistor in here for fuck knows why for. Doesn't even need to be in there. Man, I'm getting grumpy. Woo! Man, it might be time to go get something to eat. The other thing I wanted to point out was this. This is a telltale sign here. Okay. When this trace gets burned up, this tells me right away that what somebody did was they unplugged the fan and the remote jack while the on switch was in the on position up here, causing a momentary short as the stereo jack came out. And because the fuse has been bypassed, okay, there's no safety margin anymore. Backs up through the switch, goes down through this wire, poof, pops that trace. Okay, this is part of a 12-volt lead. This takes off, goes underneath the board, and eventually winds up back. It's like over here, where it makes contact. 9 times out of 10, because the trace is so small right here, it blows it here. Every once in a while, it'll blow it underneath the board. And then you got to either jumper a wire from the end of here over to here, or you pull the whole board up and repair the trace. So it's a direct result of this right here. No fuse. Has to have fuse. Has to have fuse. Has to have fuse. Because once you replace this with wire, now it's going to blow underneath. This is no longer the weakest link in the box. That makes sense? It makes sense to me. All right. So when we come back, which most likely will be tomorrow, because I've been out here all day and I'm tired. It's 6:30 at night and I've been out here since 8 o'clock this morning. So tomorrow, we'll pull these out, pull the transistors out, and we'll get busy with it. On that note, away we go. Good morning, good morning. Oh man, I just ran out of piss and vinegar for the world last night. I don't know how else to put it. I got tired of talking to people. I just got tired. It happens. Happens to the best and the worst and the kind of us. You just need to go take an 8-hour power nap. And about 10:30 rolls around last night. And I'm like, dear Lord, please, can Gonna be done talking to people. My phone never stopped going off yesterday. It's weird. It runs in cyclics. Like, every once in a while I'll have like a day or two where my phone doesn't ring a lot. Okay? And it's the same situation we left off with yesterday. The phone won't ring an awful lot. It'll ring maybe once or twice, and I'm like, whoa, phone's broken. That's what I used to think when I was a young, naive man that didn't know anything about anything. And now I'm an old, naive man. Still don't know anything about anything. But I'll say this. The day the phone doesn't ring, I wince. Absolutely wince, because I know the next day or so I'm going to have a day from hell. Yesterday was a day from hell. It's very busy. It's very busy. Lots and lots of phone calls. Lots and lots of stuff going on Facebook in the group. Did a live feed. Did a premiere, which was fun. That interview with 300 was fun. It was just fun. And by chance, I happened to pick up the other amplifier he sent me to work on just today, or yesterday. So that was fun. Yesterday was fun. Just a lot. Just a lot. Come here. Here we go. Add a pepper. So, by the time I got to the Facebook live feed last night, I'm like, okay, anybody else got no more damn questions? Okay, fine, I'm going to go die now. Goodbye. It's like I was ready to be done. Ready to be done. Okay. Transistor number 1. Curve on, melt down. Down in the hole. She's feeling so low. Okay. I'd like to shine. Come on, man. People are waiting on us. They're getting older by the second. I want to know how the mystery transistors come out. Oh, there we go. Okay. Let's see how we do here. Let's grab our Atlas DCA 75. Shorted. Diode junction failure. Okay. Diode junction failure. All right, 2 dead Toshibas. Well, that answers that question. Well, we have the result, not the result everybody wants, but we do have the result. And unfortunately or fortunately in this universe, I might identify as not being these transistors being dead, but in reality they're still dead, even though they identify as not being dead. Bruce Jenner is still a fucking guy. So now we're going to go over this. just as a teaching experiment. Okay. Now my buddy 300 here doesn't care anything about sideband. But how the bias circuit in this unit is controlled is with this resistor and this trace. Okay. Now I've lifted each one of these so I can test the value on them on each board. This is the stock resistor for this location. Now what do we see different about this resistor other than its value? Let's look right here. So this one, this section's running in Class B. This section's running in Class B. And because of this short to ground right here, when whoever replaced this resistor, they soldered that over to ground, this makes this section Class C. And then, let's go look here at this section. Same problem, Class C. So half the board is running in, or half the amp's running in Class B. And the other half is running in Class C. Now we're setting ourselves up for a massive imbalance in operation. So, .7, that's within spec. Oopsie, come here. Hold on. Doesn't really matter, I'm going to replace all these anyhow and make it right, but that's within spec. So, let's mosey on. That's within spec. Now our problem child down here on the end. It's also within spec. That might have been where our imbalance started. I don't know, I still haven't found what I'm looking for yet. What I'm looking for is the crazy ass smoking gun that says, "Here, pay attention to me." I mean, this would kill this amp. What we're looking at here will kill this amplifier eventually. Would it have been within 1 or 2 keys? Nah. Let's take our old trusted solder wick here. Yeah. Let's get in here and let's clean this up. We'll pretend for a minute that we're a legitimate repair center here. Kind of am, kind of not. Suck some of this schmoo out of the holes. Because God knows we're going to add some slobber to this when we're done. Okay. All right. Change out our 1.8 ohm resistors so they're all the same wattage rating, although that doesn't make any difference in how they operate. I just feel more comfortable when I have new tested parts in there. We're going to give this an alcohol bath real quick to kind of clean it up, more to clean the pill pockets out. And then I don't understand why we needed to do this, you guys. This is all I can't. I don't understand what's going on here with this. Why isn't this Teflon? That's what I don't get. It should be Teflon. And why couldn't we just put that in there with everything else? I don't get it. Okay, I got some stuff I want to rework and make look pretty on this. And yeah, we'll be back. I got to clean this up, and clean that up, and what the hell? Okay, so we gave it a bath, and we got all the flux out of it. Now, in the process of moving the cabinet around, I couldn't help but notice that the fuse holders, none of them except for one, had a retaining collar on it. And the other one that was on here was broke. I mean, flat out broken. So I went, all right, no biggie. I don't use these for anything anyhow, really. I went ahead and I put rubber boots across the back to fill the holes, and then put a grommet in here for the 4-gauge wire that we're going to use to power this thing with. And then I went over here and I started taking the combiners out of it. So here is the combiner for that 4-pill section. That resistor is cracked in half. It burned up so hard. And the wires that go around that, yeah, they're fucked, to put it lightly. This is the way the final combiner sits, like so, inside the amplifier. Let's rotate this around. Not too bad, looks pretty burned up. Not, oh, yeah, that's a definite problem. And then its corresponding balance resistor is burned where this would have been faced towards this wire wrap. So this is our this is our first turn on this wire, and our last turn on the output side. So it's dead shorted. I mean dead shorted. That would explain everything. So what do we learn from this? Sometimes it takes a little bit more than changing the pills to be able to figure out what's going on. I honestly don't know why everybody doesn't do like what I do. I know it's not very cost effective as far as time. Maybe that's the answer. It probably is the answer. Because I'll spend a day and a half working on this to make it perfect. Where the other guy just wants to put pills in it and get his money and send you out the door. My goal is to not have amplifiers come back here. I'll put it to you like that. I want to repair them to the point where the customer gets it. And they're like, okay, I'm not going to beat the shit out of it. And it's repaired in such a fashion that it's easy. Well, easy would be the wrong way to put it. It's repaired in such a fashion that it's at such a high level that nothing is overlooked. And it allows me to have the comfort of mind of knowing that I'm not going to have to keep dealing with the same box 2 and 3 and 4 or 5 times. I mean, there's a lot more to it than just changing pills out. I mean, there are days I wish I could just be a pill changer. I'm not going to lie. There are days. But then I go, I can't be like that. I can't be like that. Anyhow, off my soapbox. Let's get some new transistors in these holes over here. Let's get some new 10 ohmers in here, and let's get this mess turned around so we can start moving towards getting it finished. I'm going to drill a hole here, drill a hole here, and we're going to put a distribution board in here. I don't know why us as craftsmen in this industry have such a hard time with just slowing down, cleaning everything up, making everything look pretty, putting the fuses in the right place. I don't know. But it's done. This is got all the right parts in all the right places now that I can gauge. I won't know for sure if we're actually running in balance until we actually put power to it and run it here in a minute. I rewired the entire remote section, so it makes sense to me anyhow. This is your fan hookup, okay, and this is your remote switch here. So the center tip is hot, and then your jacket pin on return is going to be your on, so standard. And yeah. Wait a minute. Got this labeled fan, and this one's remote. I wired this backwards. Hold on one second. That was tough. Okay, so this is your fan, this is your remote, and I don't like the Sharpie labels. So let me walk over here and grab my label making machine. And we turn this on. And we're going to say FAN space remote, hit print. And let's put you some labels on the back of your amplifier. Okay, so we're a lot farther along than what we were in the last video segment, and I was going to shoot another segment and then another segment, and then the phone kept ringing. Anyhow, so I took off last night. I got to where I had the upgraded power wires in, but I didn't have any of the distribution network in this. And I took off and went and spent the evening with my wife. She's up camping and being an equestrian horse lady in the woods. And anyhow, I got up this morning and I come out here to come finish this thing up, and I put the power wires in it, the distribution network, and I put my Anderson clip back on. So we got rid of the, did I save that power wire? No, I pitched it. I got rid of the stock wire and threw it away. Put the Anderson clip on, I come over here and I hook it up, and it don't do nothing. So what I should have done was stop and grab a video segment, but I was on the phone and I need to get this finished. I got a bunch of other stuff I got to move on to. So I grabbed the FLIR and I go to looking, and this whole back section of the amplifier is turning on, lighting up, and running. Of course, then we got an imbalance here at the resistor, but this whole end of the amp isn't doing anything. And I'm like, well, that's interesting. So I get to looking at it, and I get the old oscilloscope, and I probe and I probe, and I got RF going in but nothing coming out. So I get to looking, and this transistor here wasn't soldered in all the way. And then over here, this tab on this transistor wasn't soldered in all the way. I went, how did I miss that? I mean, the tabs are just laying there on the solder. They might have been making contact, but not very good. I went, well, all right. So I pulled all 4 of the pills out. Now, let's get down in here real quick. So if you remember back to the very beginning video segment, this section and this section had 1H's in it, and this section's got 1H's in it. Let's wait for it to focus. So it says 1H on top of those pills. See that? So I pulled all the pills out of here, the transistors, and that transistor was popped and that transistor was popped. It makes sense. Its paired partner wasn't soldered down all the way. They were popped before it even got here. So I'm like, okay, cool. So I pulled out these two transistors. Yeah, those are them. Those are the 1Hs that came out. And went, all right, no problem. And I put the transistor here and the transistor here, put them on the beta gain checker. And one was a 49 or 39 and the other one was a 40. I'm like, okay, the HFE gains are close enough. I put them in here on this board. So I went and I got into the pile of parts and grabbed 2 more transistors and slapped them down in there. So we've had to replace these 2 transistors and these 2 transistors. Now the main reason that this box quit working in the first place was a lot of very poor quality solder work. I don't know. I don't know. I don't know who did what. And I'm not pointing no fingers at nobody. Remember, it's just my job to fix what I see presented in front of me. The guy that sends me the amp, he can tell me any story he wants. I have no way to fact check that. I have no way to reference it. I just deal with what's in front of me. And I don't get up on a soapbox or a pedestal and judge. That's not my job. My job is just to fix the shit, right? Oh, allergies. Everybody's out cutting their grass today. Snot locker's running a little bit. So yeah, let's plug this in here real quick. Let's turn the amp off. So over here we have a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug in reverse back from the Bird 10,000 watt dummy load. I have to say that in every video, you guys. I can never just go, yeah, it's a normal setup. Just saying. So, hello, audio. We're down on 12 volts, and we're using the 2950 bench radio, which everybody knows I've got way detuned. So we're way down on volts. Hello, 1, 2. Let's go ahead and turn this baby on. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Now, everything's working. Everything's in balance. Let's click open our FLIR. Let's pan this back out. And let's talk about every step that I'm doing just to make it painful for everybody. We are sitting here looking at our transistors. Hello, 1, 2. Hello, 1, 2. Everything is in balance and everything is running evenly. Period. So now what we got to do is 1, turn the voltage up, and 2, increase our drive. So let's turn our voltage up. Bring on the bench power supply. We're going to slowly watch this charge up. 14. And let's give it a second or two. All right. All we did was increase the voltage. Hello, audio. Hello, audio. How did that increase the drive? Hello, audio. 20 watts in. Hello, audio. Hello, audio. Making 850 watts out. I'm comfortable with that. I'm not going to get too excited. I'm really not. Oh, yay. Let's go ahead and we'll just jump right up to the Striker 490. We're going to hit this with a lot of drive. We'll see if it stays in one piece. Okay, turn off the 2950, turn on the 490. Let's go. Check out how much drive we're putting into it. Hello, 1, 2, about 180 watts. Come down here. Click to that, to the on position. Hello. Now we all knew it was going to do that. Where it stops, I bet you about 1600 watts. So for those of you that are new, that have never watched me do several thousand of these in a row, when we put this to the 2x range extension, now full deflection when the needle's all the way over here on the right hand side, that's 2000 watts. So the halfway point, remember it's a non-linear scale, is right there. That hash mark right there, the big hash mark. That's 1000 watts. So then the 30, the 15, the 30, the 60 is 12. The next big hash mark is 14. The 20, the 40, the 80. Let's see, 12, 4, 6, 8, and 1000 over on the scale. Hello, audio. Just seeing about 1650, right? Hello, hello, audio. 1, 2. We're getting about 120 amps worth of draw. Hello, 1, 2, right? So now, let's bump this up just a hair more, because I know my buddy 300 and where he's going to run this. He set his voltage at about 15 volts or so. Hello, audio. Hello, audio. So now I'm making 17 to 18 off a radio drive. I mean, that's good enough for me. Hello, 1, 2. So now let's go look at our input reflect and make sure the input circuit's right. Let's mosey on up here. Lock the camera down so you guys don't end up looking at the ceiling. Let me just pull the screwdriver out of the way. That's a 5-watt slug in reverse between the 490 and the 8-pill. Hello, audio. Half a watt. I'll take that and smile. Could we tweak with it and get it a little bit lower? But sure, we don't know what coax link 300 is going to use on his end of the street. We don't know. Ah! Oh, did I break anything? No. All right. This Manfrotto tripod that I have, you guys, has got clamps on it that go around the legs. They're just clip-on, clip-over clamps that hold the legs up and down. And the lapel microphone got caught on one of those and got ripped off my shirt. I apologize for that. So, to not be theatrical or anything, but not get too overly excited about nothing, but my opinion, this guy is about as done as we're going to get. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Getting about as done as we're going to get for the internals. So now everything in here is Gucci. Good to go, ready to rock and roll. What's not ready to rock and roll is the fan kit. So a little reset on the bench. Pulled and shook the towel, had to get rid of all the other little bits of wire and garbage we pulled out of that. Here's all the pills. I'm going to send these back with the amp. No need for them. Duds, bastards. Okay, so let's have ourselves a little bit of fun now. This is where I get to get the creative juices flowing. The way we all seen this was wired when it come in here. Dangerous. Smattered with a little layer of stupid, smattered with a little layer of damn. So my goal is to fix all of that. Before we fix anything, oh yeah, baby. We got to make sure that what we're working with is worth fixing. Yeah. Okay. Boy, if you guys knew how hard it was to get fans right now in bulk. Whew. Every fan I don't have to replace is another day saved in my life, because I just spent a small frickin' fortune on fans the other day. And it's like, okay, one guy's got like 5 fans, another dude's got like 6 fans, another dude's got like 7 fans, another guy got 4 fans. It's the same thing with ferrite. We're having a hell of a time, guys. And if your builder's telling you, oh, I can get everything handled, they're lying to you. Shit is getting thin. That's all I'm gonna say. So, we got good fans. Let's see if we can make some goodness out of, I don't understand why it was put together a mess like this. We'll cut all this junk off of here. Pull this pile apart. I have an idea. We're working on this amp. Okay. We've been over this with a fine-tooth comb now. Double, triple verified everything's good to go in here. I go to do the fans, and I meticulously push the wires back out of the cabinet, and I lace everything up, and I make all the leads up, and I mean, we cleaned all this up, got all the wires all nice and neatly hooked up, and I wasn't even thinking about it. And I thought, okay. And I go to put the amp in it, and I got the wires running the wrong direction. And I'm like, well, shit. They should have been going back that way, right? Oh, okay, that's a pain in the ass, but sucks, but it's got to be done right. So I go to take it all apart, and at some point or another, somebody has come along and they've replaced all the screws on this fan up here, and they just cut them off. So then I had to get out the socket, and then I had to, of course, a couple of these they strip, and I had to cut them, and here we are sometime later with all new hardware up here, or new hardware here, and new bolts and shit here on the bottom, and everything's flipped around the right way. So finally, that hole. That hole. Okay. All right. Oh, man. This took me a lot longer than I wanted. But you know what? It doesn't matter. It's all done right. I'd rather be done right than be able to just haul ass through something. You get to a point where you're like, okay, I don't care if this takes me all goddamn day to get done. I'm gonna get this done, do it right, and then I don't have to think about it no more. But when you start hauling ass through shit, man, that's when you end up having to redo shit 2, 3, 4, 5 times. Man, I only want to deal with shit one time. I don't know about the rest of you, but that's facts, man. We'll get in here like a ninja, get shit done, and get out of here. And of course, we're one screw short. Let's go over here to where we make more screws. The screw fairy just dropped this off at my house here. Okay. I'm sorry. To me, that looks a lot more professional and is a way better layout than what we had going on when we initially started. The inside of that thing is perfect. Now the fans on the outside are right as well. It's the little things that bug me the most about some of this stuff. I had a friend of mine when I was a young man. His name was Hugh, aka Junkman. Those of you that watch all my YouTube videos know that I was able to find his amplifier and fully restore it. And Hugh taught me when I was a young man. I was helping him with his computer, and he says to me one time, he goes, you know, when I take this over to my buddy Josh, or Kevin, or whatever the guy's name was, I don't really remember it, relevant really to the story. Hugh smoked like 14 packs of cigarettes a day. I mean, it's crazy. The guy would chain smoke like you've never... A cigarette lighter would last him 3 years. Okay? He'd use the cigarette lighter in the morning to light his first cigarette. He'd chain smoke all the way through his day. No joke. He'd literally light one cigarette off another cigarette. All the way through his day. He'd put his cigarette out for dinner, because that was holy. You don't smoke during dinner. Use his lighter again after dinner. Chain smoke until he went to bed, and he'd get up probably 2, maybe 3 times in the night and have a cigarette. Anyhow, every time I'd ever work on his computer, it was covered in cigarette jizz. I mean, just covered, right? And he would go, well, every time I'd take this over to so-and-so's house for him to help me with my computer. You gotta remember, this is like DOS 6.0, okay? Or 5.0 or whatever. I've been doing the whole computer thing since I was, well, VIC-20. First computer ran on cassettes. I'm talking not CDs, not discs, like what you used to get audio on, a cassette tape. He goes, he'd always clean it before he gave it back to me. I'm like, well, I got your computer running from you looking at porn and giving yourself some unknown virus back in the day. And, okay, fine. And I found it's the details that really matter in the end of the game, like taking the time to clean the on-off switches. If I was a customer, I'd want my amp builder to do the same for me. 300, you're done, my man. We're done. I'm out. I'm gonna go do other stuff. Brother, I appreciate you and all the guys that have tuned in to watch this. I want to say thank you as well. You got a problem that you can't solve? Call me. I'll try to help you get it figured out. Question about something? Call me. I'll try to help you get it figured out. 9 to 5, Monday through Friday, Mountain Standard Time. If I don't answer your call, odds are probably pretty good I'm going to call you back. Listen to the message. If you feel it's necessary to leave a message, please do so. I try to clear it out at least once a day. Usually fills up every day. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. I'll see ya. Bye.